Hello, Namaskar and Adab to all of you. So today our topic is vectors. Now in physics, as I had already discussed in my first video, that we have physical quantities. So physical quantities are of two types. Number one is a vector, number two is a scalar. In fact, these two classes, they come in a class that is called as tensors. A tensor of rank 0 is called a scalar, and a tensor of rank 1 is called a vector. But right now, let's try to take a simple way that we have physical quantities which are divided into two categories. One is a vector quantity and one is a scalar quantity. So what is a vector and what is a scalar, that we'll be discussing today. A scalar quantity is that physical quantity which has only magnitude and no direction with it. And a vector quantity is that physical quantity which has both magnitude as well as the direction associated with it. This is our definition till now. So it's fine till now, but as we see a physical quantity in physics, that is electric current. So as we see electric current, it has a magnitude. We say 5 ampere current. So 5 ampere is its magnitude, so it has a magnitude with it. And it has a direction as well. So then, according to our definition, it should be a vector quantity, but it is a scalar quantity. Now, what is lacking in our definition is the algebra of the two physical quantities. That is, the scalar quantities follow normal algebraic laws, whereas the vector quantities follow vector algebraic laws. So we'll improve our definition and make it like this, that a scalar quantity is that physical quantity which has a magnitude with it and follows normal laws of algebra, while as a vector quantity is that physical quantity which has a magnitude with it, a direction with it, and follows the vector laws of algebra. So this is till now our scalar and our vector quantity. In vector quantities, we have so many physical quantities like displacement, like acceleration, like force and all. So these all are the vector quantities because they have direction with them, they have a magnitude with them, and they follow vector laws of algebra. So out of that criteria, we classify those physical quantities in vectors. And the other physical quantities like speed and all, we can classify them in scalars. The topic of vectors provides a natural introduction of mathematics to the physics. As I had already told you in my first video that mathematics is the language of physics, so this topic is a natural introduction of mathematics to the physics. The modern notation of the vectors, how we represent a vector, that was given by a physicist of Yale University, and his name was Willard Gibbs. Now the question comes that why do we need vectors? Let's try to imagine that a particle is moving along a straight line. So there are two possibilities of its motion. Either it will go in the forward direction or it will go in the backward direction. So if we consider that its forward motion is a positive and its backward motion is negative, so it's fine. We have a plus sign and a negative sign with a physical quantity. But if we take the same system in 3D or 3 dimensions, there we necessarily need a vector. So this is why we need vectors in physics. There are lots of applications of vectors, and physics without vectors is nearly incomplete.
So we talked about vectors, right? Vectors. Now the vectors have magnitude as well as direction, right? So vectors have both magnitudes as well as directions. Now we'll first see what is a vector representation. Vector is represented like this and by an arrow here, right? This part is the magnitude. It represents the magnitude, and this over here represents the direction. So this is the magnitude of the vector and this is the direction of the vector, right? Now this was about the representation of the vector. So we can say that vector is a directed line segment. Directed line segment, right? Now before going to the vector algebra, let's first study about some terms related to the vectors. Number one, we have a unit vector. As I already told you that a vector is represented by an arrow like this, and this part of the arrow represents the size or the magnitude of the vector, and this gives its direction. So from here we can say that a unit vector is that vector whose size is equal to 1 or magnitude is equal to 1, and it points in any direction. So its direction is arbitrary. This is our unit vector. Number two term which we have to understand is, what do we mean by resultant of a vector? Resultant of a vector. So what do we mean by resultant of the vector? The resultant of the vector means the vector which produces the same effect as produced by its components individually. So this resultant, if we have two vectors, suppose A and B, both of these are vectors. If both A and B are vectors, so what effect A and B will produce together, and that will be equivalent to some vector, suppose C. So that means C is the resultant of A and B. Now this was about the resultant vector. Number third, which we need to understand, is we have base vectors. Base vectors. What are base vectors? Base vectors are a set of orthogonal mutually perpendicular vectors. Perpendicular vectors, right? In a particular direction, suppose for x direction we have I cap, suppose for y direction we have j cap, and for z direction we have k cap. These terms we need to keep in our mind. One more we have over here, that is position vector. Position vector. So what is a position vector? If position vector is this, like if we have a Cartesian plane like this, and we have a vector, suppose over here we have some vector like this. Now this is the origin 0, 0, and now we need to establish a position of this vector with respect to the origin. So this vector over here, which we draw, suppose this is r cap, represents the position of this vector with respect to this Cartesian plane, right? So that is what we mean by the position vector.
And with this, I'd like to thank you all for your attention and look forward to see you again. Till then, keep liking, keep sharing, and do subscribe if you didn't till now.